Alright, welcome. I want to make a video about curvature. Okay, if I'm standing on an ice lake or something like that, well, it's 8 inches per mile, which is 8 inches the opposite direction mile. Okay, so basically how is it possible to walk from this location to here, which is 8 inches below my level and below my level? How can I walk to here and this original location be 8 inches below my feet? Because if you work it out how many degrees it is for the whole circle, for the whole circumference of Earth, you get 360 and divide it by 24,900 miles, or 40,000 kilometers. So you can work it out in kilometers or miles. So for me to walk to here, this location is going to be 8 inches above my feet. Do you understand that? The only way for this to become 8 inches below, which would be here, which would be from here to the 8 inches, you understand that? If I'm standing here, is if the Earth moved. Do you understand that? Because you can't walk around a ball and eventually you're going to be facing over here. Gravity doesn't determine direction, your senses, to know which way is up. You know which way is up. You're always in this location. You're always perpendicular. Okay. The only way you can travel around a ball, I'll zoom out a little bit, is if you are the person, and when you walk, the Earth is moving under your feet. And that's the only way plausible. It cannot happen any other way. For you to walk 1 mile and it's 8 inches below, how can the original location be 8 inches below your feet? That means that when I walk out here, okay, that means the Earth is moving like this as you go around and follow that so-called curvature. That can't be possible unless you are actually stationary and everything moves when you move. But then we have another big problem. You're always upright and the Earth rotates in 24 hours 360 degrees. Do you understand that? When I rotate, okay, the level is changing. The 8 inches is now above my feet and now it's 16 inches below my feet. And to work out every angle for every mile, it's 0.0144, because if you times that by 24,900 miles or even 25,000 miles, you get 360 degrees. So it's basically giving you an angle per every mile, and if you work that angle out, it's 8 inches and 8 inches either side of you, which would be 16 inches here and 16 inches here. So that's basically proves to me that we don't live on a ball. Then we have this problem of the Earth spinning and the atmosphere following. Okay, have you ever taken a chain off your push bike and tried to ride it? It doesn't work. There's no friction to turn the back wheel. When you have a high pressure, and then a low pressure, and then a high pressure, and then a low pressure, and then a high pressure, and then a high pressure, well, this high pressure needs to push off something. If the atmosphere here is a low pressure, this high pressure can't push this low pressure. It's just going to fill the space. So for the Earth to spin, the pressure needs to be the same all the way around. Like they try and say, oh, it's a train. Well, the Earth isn't sealed like a train, okay? The Earth doesn't have a roof sealing it, apparently. So if the Earth doesn't have a roof sealing it, like how a train has the pressure gradient the same in the whole train, that's why when you move at the constant motion, you don't feel anything. But you rip the roof off, so it's just the ground or the base of the train, and then see what happens. The wind and the force is going to create destruction in that train. You only have to remove the front window and see what happens. Well, the Earth doesn't have a front window and it doesn't have a roof, okay? And this just totally proves to me that the Earth is stationary. You can't have a high pressure and then a low pressure. This high pressure is just going to go into here. You can't say space. This section of space, okay, is connected to the Earth. They're independent, because it's like spinning a ball. You spin a basketball, the atmosphere doesn't follow the ball around. The ball spins, you get drag. The wind stays behind, it gets left behind. Do you understand that? Then we have measurements, okay? This is why you measure a globe. It's because the Earth, okay, you have a road for an example, okay? Let's zoom this out a little bit. Okay, we have a road. But the landmass, when I'm standing here, the road actually angles in. So what is actually happening to the land? The land is actually warping and bending. This is why you think it's a ball, because you're measuring perspective. You're not measuring correctly. Everything, even in a plane, this is how it appears in a plane. The further away it is, it compresses, it compacts. And if I was to walk from this end of the road to the other end of the road, do you know what happens? It goes like this. And then when I'm at the other end of the road, it's back like this. So it's actually changing. Things are moving, they're morphing, they're warping. Okay? But I'll just leave that. Sorry. If the Earth and the atmosphere is spinning with the Earth, how do you get a north wind? Think of that. Go and think about that. Yeah. How do you remain upright and level continuously and the Earth is spinning? It doesn't make sense. Then we have perspective. I showed a video of my drone, how angles change over distance, or how much of an angle will change over 20,000 kilometers. That's basically from one pole to the other pole. How much perspective? Depending on the height is how much perspective you're going to get. If you have something at 100 meters and you're 20,000 kilometers away from it, do you think you're going to see it? Even if it's 1,000 kilometers at 20,000 kilometers away. The perspective, the sky and the ground are like a hallway. They converge. It's just a 10,000 kilometer high hallway and a 10,000 kilometer long hallway. That's the difference. You see a hallway as this 2 meter high by a kilometer long. No, the sky is a massive hallway. It's perspective. But anyway, I'll leave that with you. Have a good one.